It is time we discuss the implications imposed by my imaginary scaling factor. So, given the scaling factor is imaginary, its square that sets the sign of the spacetime interval implies that between time minus lambda and 0, the allowed speeds are beyond the speed of light, rather than below it, to keep the sign of the spacetime interval consistent. This means that at the transition between signs, when the scaling factor was 0, at the singularity, all points became equidistant for a moment, and everything slowed down below the speed of light, which is 1. If we posit that some particles already existed at that period, given the traveled distances were great, the collisions were as great, and the particles couldn't settle down to form clumps. They were flung away pretty quickly, which means that massive particles were making a whole lot of noise for a long period of time. The sound waves need to have been amplified or lowered down depending on the value of the half-life of the ultra-speed process and the value of the frequencies involved. If the evolution of ultra-speed is slow enough, equilibrium can be reached by my universe, and the patterns would be pretty regular. While the ultra-speed increases to reach 0, new equilibria can be reached, and the signature would get more and more complex. If there is any simplicity to the said signature, it would be owed to the ubiquitous nature of the function that helps the ultra-speed grow. In essence, what we have just found is that my universe might in fact display features akin to the baryonic acoustic oscillations that we observe in our universe. But remember, this is my universe. The shape of the BAO needn't be the same. Still, we could hopefully try to make a copy of our universe into my universe with appropriate tuning, I think. Let us put this aside, and consider the evolution of the cosmological parameters of my universe, by deriving the modified Friedmann equations that govern it. Owing to the modified Friedmann equations shown here, as well as the modified continuity equation, we can first establish the much-needed equation related to the parameter of state W. We establish a link between the state parameter W, the density, and powers of the ultra-speed as shown here. All of these equations depend on the ultra-speed, but not on the scaling factor, which is expected due to the tensor building that we have been through. This is extremely helpful since we can make appropriate calculations concerning the evolution of the universe in some quite generic situations that I need to explain. So, as we have established the way the ultra-speed evolves, we can posit that we only need for the ultra-speed to be monotonous, increase towards 1, and have a continuous first and second derivatives. Thus, both its first and its second derivatives will tend to 0 at infinity, which allows us to find the regime of the density and pressure at infinity. This allows us to consider a few cases that impose different values for the state parameter and thus affect the behavior of the cosmological parameters at infinity. So, for instance, if the space curvature is negligible compared to the cosmological constant, the resulting state parameter is W equals 1, and the universe is governed by the cosmological constant, which lends its value to the density and pressure of the universe. The cosmological constant becomes the matter density, so we can be sure that the regular density is whatever constitutes the mass of the universe. This caused a surge of thoughts in my head, where I started reviewing my understanding of whatever I thought positive energy density does to the universe. It seems what we tend to think of as curvature is a form of stretching of the fabric of space causing, rather than a contraction, an availability of more space in more confined regions. This affects the geodesics along which things can move, causing gravity. In case of black holes, this reframes our understanding of the red-shifting traveler that an observer far away is looking at. It seems as though the number of possible steps towards the event horizon is increased, which makes an equivalent number of steps towards the event horizon seem slower and slower. While a viewer far away sees that as redshift and feels that space is distorted, it seems that the traveler has gone through a journey to an ever-receding place as his ruler adjusts to the density of space steps. This suggests that even an observer near the event horizon will find that as he approaches the target would grow further and further. This would mean that in the Big Bang era, the reason why space inflated to begin with is because of the matter density that stretched the universe. So, the reason why the universe expands is not so because of some odd dark energy thing, but because of regular mass stretching space, making more of it, and flinging it away outside of its vicinity, in the form of gravitational waves. This segues into the idea that moving masses would keep stretching space and losing grip of it as they leave the area, which would lead to a dynamic effect where two masses that follow each other in their respective paths would cumulate each other's effects, and the resulting geodesics would involve a tendency to move faster than expected due to the elastic nature of this process. Thus, we retrieve the effect of dark matter, with a process similar to aerodynamic drafting that we can observe in racing contests, where mass in the wake of another one leaving a curved region has less stretching to do, and thus, can keep more of its earlier motion and benefit from that drafting effect. This effect may possibly be observable in asteroid belts, though I would suggest that it might need more large-scale structures, since the movement of the solar system where the said asteroid belt is, might cancel the possibility of the asteroids benefiting from the wake of each other's motion. The idea being, that with an elastic spacetime, in the center of a galaxy, where the paths reinforce each other, the clusters need to do less stretching as they benefit from the paths of the clusters ahead of them, so they can virtually lend part of their mass as something that can affect the gravity outside of those regions, far enough. Which means that the speeds are thus greater in the outer regions, due to an observable greater mass in the center. The idea is that, mass that doesn't have to do too much bending, would be allowed to cause a ripple that can result in a higher perceived mass from far away. The more liquid this process is, such as in very large-scale rotating structures, the easier it is for phenomena attributed to dark matter to arise. I'm sorry for this episode full of speculation, but it kind of felt right to sometimes draw anticipated conclusions. This is my way of repelling viewership that is only concerned about reality, and sometimes mistakes what is real with what is beautiful. This sounds like a good time for a break. See you after the redirect, late watchers of the playlist.